Good day to all of you, and welcome to my channel. So, today we are going to discuss about how to do a one-way ANOVA. Now, here, unlike other videos, here I want to talk to you all about how to understand the nature of the study, and then after that, how to transfer our data to a statistical software. And then after that, I'm going to tell you how to run a one-way ANOVA. So we are going to discuss about all three of those. And recently, I developed a very simple study. This is just a hypothetical scenario. I just wanted to uh, develop something and show how exactly it's going to work. But I hope by this you would understand how and why a one-way ANOVA is done. So without further ado, let's just try to understand how the application and interpretation is done for a one-way ANOVA. This is the study. So here I have given a very basic introduction so that you can understand how exactly we are going to approach this, okay? So here it says, Wail and Mahmood are university students. They are working on a project to understand the impact of flashiness of a casino and subsequent willingness of individuals to spend money. Here's the basic understanding. The flashier the place looks like, the willingness of someone to spend money would go up. I was recently listening to news, and where some were saying if you, for example, if you want to make an airport or something, it would be better to include features of a mall and places to relax and lounges and all of that so people can spend more money. Obviously, that is going to be earnings for the airport. So very similar to that, even if you are in a hotel or casino for that matter, there needs to be places for people to spend so that people will consider spending. So here, because of this, I'm going to consider this logic that flashier a place looks like, the higher people are going to spend. Now, with the help of their class instructor, flashiness of the casinos identified. Now, I have divided these casinos based on their flashiness into three groups. Now, once again, this hypothetical scenario, but I hope it would make sense. Uh, Cowboy casinos, so American Indian casinos, let's say the least flashier ones. And then we have casinos in suburban towns, those are the moderate, flashier ones. But the flashiest ones would be the big casinos in towns like big cities like Las Vegas, Atlantic City, Baltimore, and so on and so on. So just get the logic like this. Okay, that's it. And now, if you are an international viewer, don't try to think that I'm being racist. That one has considered the lowest and one has considered the highest. Feel free to swap around as well these name because I just wanted to show how the one way ANOVA works. And other than that, I don't have any intention of discussing about casinos here. Now, before we start, let's try to develop a hypothesis for this because it's very important before you do your analysis you have some kind of a hypothesis. So I'm going to just develop that here. So for a one way ANOVA you need to have one hypothesis. So I'm going to write my h1. One usually we write as a subscript just like this. You can click on this option, then it works just like that. So h1 you can write like this, and then after that you can write the hypothesis. uh, the degree of flashiness has a statistically significant influence or impact on willingness to spend, something like this. Now, here in a situation like this, we have to very clearly understand, although we have divided casinos into three groups, the reason for division or reason for this categorization is because of the flashiness. That's a variable that we are interested in understanding. We are interested in understanding whether variation in the flashiness of a place has something to do with the money a person is willing to spend. So you may even consider renaming this as, instead of saying type of casino, maybe you could consider the degree of flashiness, and then maybe you can categorize them as least flashy, moderate flashiness, and then highest flashiness. But in my example here, I haven't used that. But the thing is, if you use a different system like what I have used, you have to be a bit careful when you interpret. But we will get to that interpretation a little bit later. But let's focus on this right now. Now let's try to identify again what is the independent variable and the dependent variable. So here the independent variable is the degree of flashiness, or flashiness for that matter. And then what is our DV? Our DV is dollar spent. Okay. Now, as per the criteria Weil and Mahmoud have developed, how many groups are identified in the independent variable? Now, I have here given the data set as well. It's very visible. Our independent variable has three groups. The least flashy, that's cowboy casinos, and then the moderate ones, suburban ones, and then the higher ones, the big town ones. So therefore, how many groups are identified in our independent variable? That is three groups. I'm going to just write this as well. Now let's take a moment to go through our data. Now this is not a typical data set. Consider this as something that a novice person has entered. Now you know this data cannot be copied and pasted to SPSS, or here I am going to use Jamovi today. You can't copy and paste it like this. So I am going to first transfer this into a Jamovi friendly or SPSS friendly format in Excel. Now we have data from 12 individuals from cowboy casinos, 12 from suburban casinos, and then 12 from Trump Taj Mahal. Now these are not the same individual, these are different individuals. It's just that I have put it here as 1 to 12. But you know, this one way ANOVA, so obviously it's not a repeated ANOVA, repeated measures ANOVA. So if it is independent groups, a person who appears in one of the groups should not appear in the other. So altogether we have here, how many? We have here 36 people. I am going to just first copy this data to Excel. Now, if you are using a Windows computer, you can go for a paste special and just select values, and then it will take all the dollar signs out because we don't need the dollar sign here. But in my Mac, I don't have that option apparently. I do have the option of a paste special, but I go with text and still the dollar sign appears. So what I can do is I can click on this search button right here. There's a small button. You click on this and click on replace. And then I'm going to replace my dollar sign, match with the cases, and then replace all. Boom, it goes away. Now, now if you are a first year student, it's very important you learn how to do this as well. Now, type of casino. Now I am going to name my casinos. I'm going to give the value of 1 for cowboy casino. So I'm going to just type this here, 111 for all of these. Because remember, we need to do this in a SPSS or what do you call Jamovi friendly fashion. And now I'm going to paste my data for the suburban casinos. Again, same process. The reason why I selected text is because I don't need that formatting, tab boxes and all of that, table boxes. That's why I did that. Okay, I'm going to replace this guys as well. Okay, now that is also replaced. And now we are going to name this as 2 because this is the other type of casino, suburban. Now I need to transfer the last one, that is Trump Taj Mahal's data. Okay, copied and pasted, match cases, replace all. Okay, that is also done. I'm going to write or include number 3 for all of this. Now let's transfer this to Jamovi. Now you can directly transfer this as well. I mean, no problem with that. It's just that it keeps on giving that dollar sign in Jamovi, so we don't need that dollar sign. So let's open Jamovi. So if you open Jamovi, it would look like this. Now first go to this data view, and I'm going to enter my data here. I need to copy and paste all this data. This is the tab for degree of flashiness. So I'm going to just copy that data here. Okay, done. Data for 36 people is now copied. Now I'm going to copy the number of dollars or the amount of dollars each person has spent. Okay, let's click on this. Done. Now I don't need this Excel file, so I'm going to just close it. And here they have given an additional variable. We don't need that as well, so I'm going to just delete it. So it would be better to keep this clean. Now I have just added the data, but I haven't really named my variables. So I'm going to just go ahead here and name my variable. So if you click on, you do a double click on this A button and B here, like the column header, it will give you a chance to rename this. So now I'm going to rename this. The first variable should be what? First variable should be, maybe you can write it as type of flashiness or type of casino. But here I'm going to write just type of casino. But if you want to make this more comprehensive, maybe you could just say flashiness. This is a nominal variable, data type would be integer. The first one, number one, represent cowboy casinos, which is the least flashy option here. So I'm going to just type this. See, it suddenly changed everything to least flashy. But still, the software knows that number one represents that, so it can make any calculations with that. The second one is the suburban one, that's the moderate flashy. And my third here is highest flashy. Now you might notice mistakenly I have selected a couple of variables here. So limit it to just the first one, then no problem. If not, that's why earlier, if you saw the thousands and all of that, because earlier it had included this as well, this B column as well. We don't need this, so I just limited myself for the first column. Okay, now that is added. Now let's go for this, the second variable. Here I'm going to write it as dollars spent. This is not a nominal variable. This is not a nominal variable. And last time, I think I mistakenly have added something here. We don't need these guys. Okay, that is removed. So these are just data of people, how they have spent. So I'm going to just consider it as continuous because it's not a categorical variable. Now you can just do one swipe and see whether your data looks all clean. Oh, see, data seems to be all added very nicely. Just two variables and nothing unusual is happening here. It's very clean. And now you can understand what is happening. Now, at this moment, if you want to save your data, you can save that as well. You can just put a command and it's in a Mac. If not, you can go ahead and save from here. The save as option. But I'm not going to save here. And I'm going to just run this analysis. Now, I need to run, here I have given some questions. I need to run a descriptive analysis, and I need to also check for the normality. And also I need to go ahead and run my one-way ANOVA. But I'm going to first do this. I need to first check how much dollars are spent on an average by the people in my sample. And I need to then split it by the three groups that I have as well, by the degree of flashiness. This is just us seeing how descriptively something works. So let's click on this option here. Let's give me a second. Let's click on analysis, and then I'm going to explore my data. I'm going to go for a descriptive set of analysis. Now I'm going to just consider first my dependent variable. So select your dependent variable and you would see there's a variable tab and a split by tab. This split by is used if you have a grouping variable, like for example, flashiness. I have three groups. I can do more analysis with that, but before that, I'm going to just transfer my data to this right side. Okay, like this. Now, here, if you click on the statistics option, you can select what kind of data is important. Now, N is the total sample size, that is 36 already given. There are no missing values, so I'm going to just remove this. If I declick this, it will go away. I need the mean, but I really don't need the median, so I'm going to just remove that tag. So I need to keep this simple here. And standard deviation is given. Maybe I can keep minimum and maximum. That is good because uh, on an the minimum a person has spent in this data set, in this full data set, is 1,000, and the maximum a person has spent in this data set is 48,000. So for 36 people, that's a huge amount of a range. And maybe because there are different degrees of flashiness, so in certain ones people have spent more, and certain ones people have spent very low. Now I need to get some understanding about the distribution of the overall data. So I'm going to just go and see the skewness and kurtosis as well. Now, this is generally values closer to zero are considered very good, so that the data do not indicate a skew, which means a tail to one of the ends, and it is not it doesn't indicate any kurtosis. But if you notice here, these are all 2-point values. So probably my understanding is this data is going to be not very normal. But this has to be checked for each group as well. So you have your dependent variable, check whether each group comes up with the same thing. So I'm not going to do that here. I'm going to do it as my next step. So let's keep this data with us. Now, this is some descriptive data about what do you call our overall dependent variable. Now, if you right click on this and copy, you can directly paste this into your dataset. Now, I already ran this dataset. So if you want, you can copy and paste it like this. Let's say I'll show you an example. You can copy and paste it like this. But if you do it, it's very important. It's very important that you format it very well. Now, if you write a research paper, you have to format it according to APA. So click on this again, select Times New Roman, and then font size 12. If you want to double space it, you can go ahead and do that as well. So this would be then a very clean formatted table, and maybe you don't need this, and then maybe you can later put table 1 and then give the description. But this looks very good. So I don't need this, so I'm going to just delete it. But when you do your analysis, you can do it in a similar fashion. So these are my results I already have obtained, but I'm going to just run it for you so that you understand what is happening. So this is the basic descriptive, so the overall sample. Now, the idea is when you run analysis like this, you should be able to remove unnecessary things and then put them in all in an understandable fashion so that the reader can understand it very well. Now, I am going to split this information by the flashiness. So take this flashiness and put it under the split by option. Now, I can see the N for all three. All my three groups have 12 people, and then the mean for all three is given, standard deviation for all three is given, minimum and maximum is given. But I think this method of showing is not nice, so I'm going to change it to variables across rows. Now this is good. See, dollars spent, I have the least flashy, moderate flashy, and highest flashy. I have my ends, I have my mean, standard deviation, minimum, maximum. Now here I am going to get skewness and kurtosis because I need those bad boys right now here. Now it gives the skewness and kurtosis with the standard error as well. That is not really needed, but that's okay. And I'm going to get Shapiro-Wilk so that I can further check whether it is statistically significant or not. So if it is statistically significant, then it violates normality. Now let's go through this data. Now I need to understand what's the objective of my study. The objective of my study is to see whether the degree of flashiness has something to do with dollars spent. Now it is very visible if you just check out the means. On an average, people have spent roughly about $3,000 in the least flashier casinos. But you can see it has risen up to a 4,542 in the moderate flashy one. And if you notice, there's a substantial increment in the highest flashy group. Now, we already have some supporting data to go with hypothesis testing. Now, here's the thing. Now, when you run a one-way ANOVA, now here we have three groups. If you have two groups, you can do a t-test, independent samples t-test. Now here we have three groups and we are going to compare the three groups for this to support our hypothesis we identified. We need to run a one-way ANOVA. Now the one-way ANOVA will tell whether what we are predicting is, what we are hypothesizing is significant or not. But we need to compare each group as well. For example, ANOVA will tell whether these differences are statistically significant or not. But I need to check whether these differences between the least flashy to the moderate to the highest, and then least to the highest, whether these are statistically significant as well. But we'll get there. I have more things to do here in this data set. Here you have some standard deviation information as well, and the minimum and the maximum. Seems like the minimum is the highest in the moderate. The maximum is the highest in the highest flash of 48,000. Skewness and kurtosis values, I think they are pretty okay. Although for the overall sample, it kind of gave a skew, but if you divide it by the groups, skewness values are very close to zero. I think it's okay. Kurtosis values are also pretty close to zero, but I think the data kind of tends to be flatter here. And if you go with the Shapiro-Wilk data indicates these are the significant values. Only the second one, the moderate flash here one, 0.04 is less than 0.05. So only this one violates normality. But I don't think that's a serious violation considering the kurtosis values and skewness values that we have. So in a situation like this, it's very important that you spend time justifying your approach. You don't need to go for non-parametric equivalent just because this is violated. You can go ahead if you would want to, but I would justify otherwise and say maybe a one-way ANOVA is all right. So it all depends upon how you are going to justify. But then that justification is not what we are interested in discussing here. Okay, so that is exactly what we want to do. Now, I think we have already found the required information here. And we also did some normality testing. We can also now run a correlation for this. Now, the correlation here, I'm going to quickly go to my data view. Now, from least flashy to moderate flashy to highest flashy, although I have considered it as nominal here, technically that is ordinal. So I'm going to just click on ordinal as well. And you will notice even if you change it, the values are not going to change or anything. But just to do it in the right way, I just changed it. So I'm going to click on analyze. Then I'm going to click on this regression option and going for a correlation matrix here. And then I'm going to put both these variables. You can just run a correlation to see whether increments in the flashiness has something to do with dollar spent as well. I'm going to go with the Spearman correlation because one of my variables is categorical. And if you look at this, there's a 0.629. That's the correlation coefficient of dollar spent and flashiness. I think that's a pretty significant correlation. It's a stronger correlation. So that also supports the idea. Now, this is not to prove our, this is not to support our hypothesis, but this is just to give an understanding about how that works as well. So now you have some other information here. Now, again, I'm going to go back to my data. For you to run the analysis, the ANOVA, you can actually keep this as ordinal as well. But out of habit, I'm going to again just change this into a nominal because I want to keep them as just normal groups. And I'm going to again go to analyze. Now click on this ANOVA option and you have multiple options here. One-way ANOVA. If you want to run a two-way ANOVA, you can go for this. Repeated measures ANOVA and COVA. And this is a covariance MANCOVA. This is the non-parametric equivalent of ANOVA, Kruskal-Wallis. And then here you have the repeated measures Friedman. I'm going to click on this one-way ANOVA. So my dollar spent is the dependent variable. Flashiness is the grouping variables. In SPSS, I think you would notice this as a factor. So that is also all right. Now, a few things I need to do. I'm going to first select. Now, they already have given me the basic one-way ANOVA output here. One-way ANOVA Welsh, dollars spent. F value is 8.82, degrees of freedom 1 is 2, degrees of freedom 2 is 19.5, and then the p value here is 0.002. 0.002 is very significant. So our study is statistically significant. So just this information is actually enough for us to go ahead and support this hypothesis. So the data indicates that the degree of flashiness has a statistically significant impact on willingness to spend. Yes, that is accurate. The data supports that. So we can actually go ahead and approve our hypothesis. No issues. But I need to do more analysis. I need to do a homogeneity test as well. If you look at the homogeneity of variances, which is an assumption to run a one-way ANOVA, homogeneity of variances are also violated. So usually when you do a degrees of freedom calculation, you don't get decimal values like this. I think here the decimal values have come because there is possibly some correction because the homogeneity of variances is not met. So here, when you want to run a ANOVA, they ask whether variances need to be assumed or not. So if you, for example, let's say variances are assumed, see, if I assume the variances, my value changes, the F value changes, and also the DF2 has now changed as well. It is still significant, but the DF2 changes. But this has no equal variances. So because of that, because homogeneity of variances is violated, I'm going to go with the don't assume option. But I have given here both, so you can compare and understand, but I'm going to go with this Welsh 8.82, degrees of freedom 1 is 2, 2 is 19.5, and then this the final, what do you call, the p-value, the significance value. Okay, now I know if you want to get descriptive tables, you can get a descriptive table here as well. So the basic information that we did earlier, it gives it here. So I'm not going to need, I don't need it right now because I already have run it. Now here, the next option is to get post hoc tests. Now, if you notice here, I need to compare my three groups with one another. One-way ANOVA tells that these differences are significant, but I need to check which group differs from which. For that, I need to run a post hoc test, one equal in variances. There is one option, games Howell. I'm going to click on that. Now, this is the post hoc test. Similar to a correlation matrix, it lists down the groups on the x-axis and the y-axis like this in the table. And you can compare each group with one another to see which groups are actually statistically significant. Now I'm going to get the t-value here. And I'm going to get the flag significant comparisons as well. So then Jamovi will flag which ones are the most significant. Now you will see the least flashy and the moderate flashy has a mean difference of 1531, because if you remember from here, the mean spent here for the moderate flash is 4000, least flash is 3000. Although descriptively there's a difference in their spending pattern from the least to the moderate, there's an increment in the spending. That increment is not statistically significant. So essentially these are pairwise comparisons. So they have run a bunch of t-tests. And if you run a t-test to the moderate flashy and the least flashy, it is not statistically significant. This is exactly what the postdoc tells me right now. But from the moderate to the highest, there's a noticeable difference. Least to moderate, no difference. But moderate to highest, there's a noticeable difference, statistically significant difference, because the mean difference is 14,658 and the p-value is 0.16. That's a statistically significant difference. And the least to highest is also, that's a statistically significant difference of the mean difference is 16,189, and this is the p-value. Now, this difference leads to flash here. This is statistically significant at what do you call 99% confidence interval, because it gives the p-value. It is significant at 0.01, so that is 99 confidence. And this one, moderate to flashy, that is 95%. So I think pretty significant data. Now we have run our analysis. So if you run your analysis in this order, you can copy and paste them into a separate file. And then let's focus how exactly we are going to write the results section. Now here I have a sample results section. If you need to write a simple research report, now this research report is for my first year, second semester students who follow a psychology program. So I have made things in a very simple manner here. So you can transfer this data and then you can go ahead and do the interpretation. So here's how I'm going to transfer. So if you follow the APA format, we need to first have the section named results. And then here I have given a bit of an introduction. The results section of the present study contains descriptive statistics, parametric assumptions testing, and inferential statistical tests. If you need, you can give a bit of a more introduction as well, but I assume that you can give introductions in your uh, first few chapters, like introduction. You can write literature review, so and you have a method as well, so you don't need to repeat everything in every section. So I'm going to start with descriptive statistics. Now, it would be a very wise option to have Grammarly downloaded and installed so that you can correct grammar mistakes on the go itself. Because when you make a coursework submission or something like that, you don't need to have grammar mistake, because that will hinder the readability of the report. But at the same time, it will affect your grade as well. Now, descriptive statistics. So if you notice, I have taken my subtopic to the left side, and I'm going to just write it here. Always make sure you give a bit of a narration. We are not writing a novel, but it has to have some readability. There's a person who is reading this on the other side, so make sure it is readable. A series of descriptive statistical analyses were conducted to identify how the average spend varies based on the location of the casino or based on the flashiness of the casino. Let's write like that, flashiness of the casino. The location of the casino determines the degree of flashiness that explains the intention of the intention of a person to spend. Now here, if you put flashiness here, this sentence is not required, but I have already included that sentence, so I'm going to just undo this and keep this as location, so it all makes sense. Okay, now this is my table one. Now when I copied and pasted, it only gave me the table, but I included this as table one, and then I gave a bit of a description here to indicate what the table is going to be. This is the descriptive table where we have compared the type of casino with now you will notice I have taken this data some time ago. In the original analysis I have done here, I named it as flashiness. Okay, so name it appropriately. Now, when you give a table like this, don't just go for the second table without narrating this. You don't need to explain everything here, but explain the most important bits. Based on the obtained descriptive results, the highest average spending was noted in the Trump Taj Mahal. See, you can correct your grammar as well. Here I have given the mean and the standard deviation and a comma, and the lowest was noted in cowboy country casinos. Following this, assumption of the assumption of normality and homogeneity of variances were tested to evaluate the appropriateness of the data to undergo a one-way analysis of variance. Now we are going to go for parametric assumptions testing. Firstly, normality testing was tested for all three groups in the dependent variable by running a Shapiro-Wilk test. Now, I already have done this in the previous table, so I'm going to give the indication that if you go to table 1, you can obviously go through this information. So I'm going to go to table 1 and see whether I can have this, have a look at this information that's right here. So I'm going to indicate it here. You need to spend some time correcting your draft to make sure it is readable. So when the reader reads here, if he has forgotten to read or check out the Shapiro-Wilk component, then he or she can quickly go back and do the needful. So they don't need to spend time scrolling up and down. So as per the results obtained, the data associated with Dell Suburban, okay, we don't need that, Suburban Casino violates the assumption of normality. Now, reporting has to be done according to APA standards. I didn't check whether this is the right format, but I think this is the right format to interpret or report the APA for Shapiro-Wilk. Further, homogeneity of variance assumption was tested using Levene's test. The results of Levene's test revealed the data violated the assumption of homogeneity of variances, and this is how you would report your Levene's test. F value, F in italics, and then you put DF, degrees of freedom, for DF1 and DF2, and then you give the F value and the P value. Now I have given that output table 2 here. I haven't included table 2 in the description here because it is immediately given. Followed by or following the basic assumptions testing, a one-way analysis of variance was conducted. Now this is inferential statistics. Now I am going to check whether my hypothesis is true or not. For this, I am going to write a bit of an introduction and my results. A one-way analysis of variance was conducted, table 3 is given here. As per the results obtained, the average spending in casino based on the degree of flashiness is statistically significant. F in italics, degrees of freedom 1, degrees of freedom 2, F value and the P value. Now, if you use SPSS, you would get the effect size as eta squared. If not, if you use any other software, sometimes it gives eta squared, it can give epsilon squared, R squared. You can give that also immediately after this. Now, in SPSS, in Jamovi, when you do a two-way ANOVA, it usually gives the effect size, but for this, it doesn't. So that's okay. I mean, you don't need to have it. If you want, you can manually calculate this as well by getting these F values, but we are not going to do that right now. So then table 3, one-way ANOVA is given. This is a small, very small table. Here I have mentioned, although the one-way analysis of variance is statistically significant, a post hoc test, Games Howell, was also conducted to further evaluate pair-wise differences, because we need to compare different pairs to understand our ANOVA is significant. That is true, but I want to understand whether the three groups also indicate statistically significant differences. That is given in table 4. As per the, now here we have the table. As per the post-hoc test, as per the post-hoc analysis conducted, the average spending from the least flash to the highest is statistically significant. Now, this is a t-test. It's a pairwise comparison. We have a t-value as well. So you have to write in italics the t, degrees of freedom, df value is given here, 11.2, and then t value, and also the p value. Similarly, the average spending from moderate to highest is also statistically significant. I have given the t value for that as well. So we have given, now you don't need to color this, I just colored it so that I could actually show it to my students. I'm going to take that highlight out. Overall, it can be concluded that the degree of flashiness in casinos significantly impacts the intention of players to spend, or clients to spend, customers to spend. Thus, hypothesis 1 is accepted. Additionally, a Spearman correlation was conducted to see the association between the degree of flashiness and the average dollars spent. This is, of course, not required, but I just ran it, because I just wanted to see that as well. The association is also statistically significant, RS, that's Spearman, with the coefficient of determination, R squared, that's you can just square this value 0.629 times 0.629, that is 0.39. So 39% of the dollars spent is accounted by the flashiness. So not bad, not bad. So I have written that here as well. The effect size calculation indicates the flashiness of the casino accounts for 39% of the individual spending. So now we know the flashiness has something to do with the dollar spend. Now, here's the idea. Now, let's say if you are a business psychologist or organizational psychologist and you are working on a consultation project for a big hotel chain or something like that, hotels sometimes need to have some fancier options for people to, come and spend. Because end of the day, it's a business. Now, there are, uh, we live in Sri Lanka, so we are a tourist hotspot. So if you come to a hotel, the hotel has to offer quite a lot of things. Sometimes these things I don't see in hotels in other developed countries. We have spas, we have then meditation centers, yoga centers, and then on top of that you have massive gardens. Uh, Sometimes these are occurring closer to a very secluded private beach. And then on top of that, you have nice villa style rooms. And then those rooms have, dine in options. And then on top of that, you have a whole lot of other games that you can play, travels that you can do, quite a lot of things like this, right? So, end of the day, these are all different ways to get people to spend. So I'm saying it's a bad thing. It's a very good thing because the country actually need dollars right now as well, because that's a political thing. I'm not going to discuss about that. But this data supports that idea. Now here the data is just I added this data. But if you actually do a study to select, let's say even if you get hotels, small scale to medium scale to large scale, if you do a study to identify how much people spend on an average, of course, the money, there is a huge variation in the funds that you would spend, because the bigger hotels require you to spend definitely more. If not, you can't get a room over there. But if you consider a specific service inside the hotel, because hotels have bars as well, small hotels have smaller bars, medium hotels have medium level bars, and big hotels have bigger bars. But doesn't matter, a person can just have a beer wherever they go, regardless of the size of the place. But maybe the size and the amount of the detail that you would see would encourage a person to spend more as well. That is exactly what we try to do here. So you should be able to then apply this to multiple other scenarios as well. And if you go to certain countries like Thailand, sometimes their hospitals have some of these features, so that in hospitals also people would consider spending more money. So ethicality and all of that, I'm not going to discuss that here, but I just wanted to show the application of it. So that's the end of this lesson. I hope I was able to get you some understanding about how to do this analysis, and thereby how exactly you are going to go ahead and interpret. So that's it from my end for today. And I will see you with a similar informative lesson again in future. So thank you very much. And feel free to check out other videos in the playlist as well. I have 19 or so other videos on research methods. I'll give the playlist towards the end, so you can check out those videos as well. So thank you very much.